So without further ado, I'll let you take it over. N6CBO, tell us what you got tonight.
Well, first off, thank you and for inviting me to speak up there. Let me see if I can share my screen here and get my face off of here, and you can see my presentation instead. Let's see how this goes here. So can you see my screen?
Yeah.
Okay, so as we're saying, yeah, we were at Quartz Fest out in the Arizona desert. My friend Jed, N6JED, and myself went out there, and we decided to take and launch a balloon from there. But because of COVID, we had been stockpiling, I guess is a term we could call it, a number of parts and balloons and trackers and all this stuff. So once we got out there and we launched our first balloon in the morning on the first day, we decided to build another one, and it turned into a week-long balloon launch event where we launch balloons every day. So I'm going to tell you a little bit about what Pico balloons are, the general configuration of how we fly them, and there's always other options. And then I'll show you some pictures from Quartz Fest. So hopefully that you guys will be entertained with that. I don't know, really, it's really hard to answer questions online as we're going with a mixed venue like this. So I guess if you really need something, put it in chat, and maybe one of the moderators can let me know.
That's what we're gonna do.
Okay, great. All right, so a little bit about myself. You know, I was a technician, and I got my general in 2009. We did a sailing adventure around the world for 2 years, so that's why I upgraded to general. From 2000 to 2009, I really wasn't very active, but after that, I've been pretty active. Started doing Pico balloons in 2019, and I'm currently working as a hydroelectric power plant technician. I noticed a lot of you guys and gals out there were engineers. Well, as technicians, take what you guys draw up, and we make it work. So some general information about Pico balloons. Pico balloons are free floating. They're not tethered balloons. The flight duration is in days or weeks. And this is opposed to what you might hear about a lot of schools doing. A lot of schools do HAB balloons. That's HAB. Those are high altitude balloons. They generally try to go to 100,000 feet. They pop and they carry a payload up into near space, and they take pictures. And ham radio is usually used on those for tracking their location and their descent, and then finding them after they landed. As far as Pico balloon goes, we use ham radio for tracking where they are as they go, hopefully, around the world. They float at generally 30 to 45,000 feet. And there's different reasons for those altitudes, but right in that band they're floating. And they're considered a super pressure configuration. And what that means is they're not like a latex balloon. They don't stretch. Their displacement or the volume is the same for the most part from when you fill them up to when they're flying at altitude. They don't stretch out, in other words, much. They do stretch a teeny bit, but not a significant amount. And they're neutrally buoyant at altitude. So what that means is they get to a level where they want to float, and they just stay at that altitude. And then our payloads weigh from 12 to 17 grams. And for you that aren't up on the metric system, that's about half an ounce. So here's a typical flight package. We have a balloon. We have some solar panels, a little tracker, and then generally a dipole antenna. And put a swivel on there, so that helps with keep the package from rotating and flying around while it's in flight. And put a weight at the bottom to help keep the dipole straightened out. All of that has to stay within the 12 to 15 gram range. So that's pretty light, half an ounce for all of that, minus the balloon. So first off, you hear the 30 to 45,000 feet. The first question that always comes up is, what about airplanes? Are you going to bring down an airliner, et cetera, et cetera? So we'll just put that to bed right off the bat. There's actually rules that the FAA has for balloons, and they start at 4 pounds of balloons. Anything under that, they don't even want to hear about. So being at half an ounce, we're more than 100 times under the lowest limit of even notifying them of a flight. So there's no issues there with balloons at all. And most airplanes and engines are all designed to ingest, a single bird or a couple birds. They're much, much heavier than one of our Pico balloons. So speaking of balloons, there are generally two types that we're flying. There's actually a third one people are starting to develop right now and testing out. But the Chinese 36-inch party balloons, those are really cheap. You buy them on Alibaba or something like that. They're about $1.50 a piece. Or you can get a professional balloon from SBS. And those balloons run about $160 a piece. So that's the two types we've been flying. There's a new one that people are just starting to test out, and it's a spherical balloon, and we're going to see how it works out before we start trying those. But for lifting gas, we use hydrogen, and the main reasons are it gives a lot more lift than helium, and it gives a lot less leakage. And since we're looking to have this balloon stay aloft for multiple days or weeks, leakage becomes an issue. So even though hydrogen's smaller than the atoms are smaller than helium, they're diatomic, so there's two of them stuck together. So the two hydrogen atoms leak less than a single helium atoms. And any of you that messed with helium know that it just wants to escape whatever you put it in. And then finally, to protect the stupid among us, there are laws that limit the helium purity in many places. So what that is a lot of states and countries require helium that's bought like at party stores and stuff to contain a certain amount of air or oxygen in it so that people don't breathe it until they die. Anyways, enough on that. So with the balloon, what we do, we strive for a free lift, and that's how we know how much gas to put in there. And free lift is the amount of lift in addition to your payload. So in other words, if the payload weighs 15 grams and we wanted a free lift of 5 grams, we want the balloon to lift 20 grams. And that's how you fill it on the ground. As the balloon ascends, it will fill out and expand, but the lift stays the same there. So here we are sealing a couple of the Chinese party balloons. We're going to fly 2 in tandem here. And these are what we launched a bunch of them at Quartz Fest. And we're just using a regular food sealer there, sealing the necks after we've inflated them with hydrogen. And you can see there's very little gas in there, just enough to get it off the ground. As far as the payloads go, and let me stop for a second too and just qualify all this. I don't claim to be an expert on any of this. My buddy Jed and I, we've been flying these and we're learning as we go. So, you know, we make mistakes and we're learning as we do this. So I'm just kind of sharing our experiences with this. So as far as the payloads go, we have 2 different trackers we've been flying. They're both ham radio transmitters. And what we're doing is we're piggybacking on some existing systems out there. Many of you might know about APRS, which is 2 meters, and it'll track vehicles. You can put messages out there. You can do a bunch of stuff with it besides just tracking. But that's a system that exists in almost every populated city around the world. So what we do is we use that to help track our balloons. The good thing is it has a high bandwidth. It gives us a lot of data down, very detailed data. You can put cute messages you send down from the balloon and all this kind of stuff. It runs on 2 meters and it does 0.5 watt, the little transmitter that we fly. The bad news is it's on 2 meters, which means that it's line of sight. And even at 40,000 feet, while line of sight might be a whole state in the US or a country over Europe, if you get out over an ocean or over Africa or Siberia, there's no one to pick it up. So you might not be heard from for long periods of time. So with that case, we think about using HF, and there's Whisper system is out there, weak signal propagation reporting. And that's another system that exists around the world, and people listen and they transmit very low powers on this and check for propagation. Well, since that system already exists, we're piggybacking on that too, and using it to report in where our balloons are. The good thing about Whisper is it's on 20 meters or 30 meters, and at 10 milliwatts, it's routine to do 2,000 to 3,000 miles for it to be picked up. So that's great for our tracking, and it works wonderful for that. The drawback is Whisper is very, very low bandwidth, and I'll talk about that a little bit later on. There's some other ways of tracking payloads also that people use. QRSS, very slow CW. Internet of Things, etc., and the reverse beacon network. So you could do a call sign with a call sign on CW, and the RBN network would report back that, hey, someone heard you, and really won't tell you where you're at. All of these payloads are solar powered, no batteries. So that means they only work during the daylight hours, and that's the balloon daylight hours. So wherever the balloon is, it's solar day. We don't run batteries because at 40,000 feet, it's very cold up there, and the batteries will freeze and they will die. So to keep them from freezing, you have to run a heater. And if you're running a heater on the batteries, you got to run a bigger battery pack, and that ends up in a vicious circle of, not having a big enough pack to keep them warm and keep them from freezing. So that and the weight. What we do use is we use supercapacitors. Excuse me. The thing with the supercapacitors is we can use a real teeny little solar panel and charge up the supercapacitors for, let's say, 2 minutes, and then do an APRS burst at half a watt. And an APRS burst is, well under a second. So that allows us to use all of that energy in a very short time frame, and effectively gives us that half watt power for that. The Whisper is only doing 10 milliwatts, so we can run that directly off a little teeny solar panel. And then finally, all of these payloads need to be frequency agile. And what do I mean by that? Well, if you talk about APRS in the US, it's one frequency. But believe it or not, when you travel around the world, APRS is on different frequencies. So the tracker needs to know where it is and have a good fix on its GPS coordinate, and then pick the right frequency for APRS. They also need to be geo-fenced. And there are certain countries around the world where it's illegal to transmit amateur radio from an airborne platform. So to do that, and to try to live, to try to do the right thing, we geo-fence our radios. And that's, like the UK and North Korea, they don't like you transmitting from airborne platforms. So that will shut off the transmitters in those areas. Okay, here's a picture of one of the commercial trackers, and I built it out with a couple solar panels. This is the one that's currently flying right now, and I'll talk about it a little bit later, but it is in flight at the moment. It's one of the ones that I launched from Quartzfest. You can see the tracker there. At the top, hopefully you can see my mouse maybe. There's a GPS antenna. There's a GPS chip right here, or GPS receiver. There's a little computer, some power supply stuff, and obviously the solar panels. And then on the back side, inside the metal can here is a VHF transmitter. There's a pair of supercapacitors, and then some precision shunt regulators to keep the supercapacitors from being overvolted. And so that's part of our whole flight package. And talk about, okay, if you see the black squares come up, don't sweat it. That's my JavaScript running, and I'll talk about that in a moment too. So weight is the main consideration for these. Look at the different trackers. You can see they all run around 10 grams. The solar panels weigh about 1.5 grams, and supercapacitors, etc. What's interesting here is we are running a full 20-meter dipole. That's 32 feet long. And that 32-foot long, full 20-meter dipole only weighs about 1.6 grams, which is, a fraction, it's nothing. And the whole tracker, again, all of the parts that we pick for it come in at, under 1/2 ounce. So when you're launching a balloon, there's some major milestones. Excuse me for 1 second. There's some major milestones that you do. The first one is if you launch a balloon and you can receive an airborne transmission from the balloon, that's a huge goal. It's a lot of people never get a transmission from the air coming back. And then making it to altitude. And what I mean by that is the balloon's made it to altitude, it's leveled off, it's floating along nicely, and it's transmitting to the ground. So those two things are the first two hurdles, and they're way more difficult to achieve than a lot of people think. The next thing would be for the balloon to live through the first night. So your second morning, the sun comes up and you're anxiously awaiting it to report in and hear from it. So that's a major milestone. And then ultimately you want to cross, a continent or an ocean. And then the Holy Grail is to circumnavigate the globe with one of these balloons. And again, it's a very difficult task to achieve. So some of the flights we did, I don't want to go into all of these, but I just want to touch on the fact that how challenging it can be. So our first flight was only 3 days. Our second flight died on the ground. Our third flight made it 13 days. It was interesting because it went down over Emirates, and the guys at the Emirates Ham Radio Club there's 5 guys there. I emailed them. They have an entire palace, a gigantic palace is their ham radio shack. They actually have their own satellites up for 5 guys. Our fourth balloon lasted for 1 day. Our fifth balloon did really well. It ran 110 days, did 5.5 laps around the world, and went down in a giant typhoon right off of Guam. But after that, we struggled. We did some good ones. We had 7 days, a 3-day one. And then these are the ones we launched from quartzites. A lot of them lasted 2 days. And then one of the balloons lasted 14 days and did 1.5 laps around the world and went down to Nova Scotia. But the one here we're here to talk about tonight is N6CBO-15, and that's made it 67 days. It's still flying right now as we speak. And I'll give you a little update on it in a moment here. So here's what the balloon looks like when we launch it. This is one of the professional balloons. You see it looks like an empty garment bag you get from the dry cleaners. And it just has a little teeny bit of gas on the top. As soon as you launch it, it starts expanding and filling out the balloon. Oops, wrong way. Okay, so here's a balloon. You can see it up there high in the air there. Everyone see that? Okay, there's the tracker. It's just a little dot right there in the sky. There's the 20-meter dipole. Can anyone see that? No, it's almost invisible. That wire is so thin. We actually tried a thinner wire, but the next thinner wire was so thin that it was unmanageable. This wire is 0.005 of an inch, and it's just at the point where you can still manage it. And then, of course, there's me. We're launching. We're launching in the desert down here in Southern California. So the balloon that's flying at the moment, again, I said it's N6CBO-15. It weighed in at 15 grams. That's about the weight of 2 quarters. And that's all of the stuff below here. It came under that weight. So the tracker, the computer, the voltage regulators, GPS antennas, the HF and VHF transmitters, 2 solar panels. The solar panels had diode isolation on them so that if one of them failed or one of them got bent down, it wouldn't drain the other one. A couple supercapacitors, shunt regulators. Again, a full 33-foot, 20-meter dipole, 19-inch VHF antenna, and then all the rigging, swivels, weights, and everything. Again, all of that is under 1/2 ounce. So that is a huge challenge. Here we are in this tent. This is actually out at Quartz Fest. My buddy Jed, N6JD, he set up a tent out there, and we use that for our balloon assembly building. The folks were talking earlier about, these morning launches. They were right at sunrise because that's when the least wind is. And for us to launch at sunrise, we had to get up at dark 30 and go out in this tent and work in the dark and assemble these balloons and trackers and test them out. So we were ready to launch, right before the sun came up. So it was quite a challenge. I want to talk about a little bit about Maidenhead grid squares. I'm going to step aside here and then we're going to come back to the balloons in just a moment. So Whisper reports a grid square, and a grid square is 1 degree latitude by 2 degrees longitude. And what that means is it changes sizes, depending where on the globe you are. But for the most part in the USA and Europe, it's about 70 miles by 100 miles. And down by the equator, it's about 70 by 140 miles. Excuse me. So the reason that's important is when you report in on Whisper, you only get a grid square. When you report in on APRS, you get a position within a couple feet. If you're out over an ocean, you really don't care within a couple of feet. You just want to know the balloon's still alive and it's still moving somewhere. So that's the trade-off again between APRS and Whisper, or 2 meters and 20 meters. So some of the telemetry data, and that's why I talked about the grid square. Again, it's Whisper only sends out your call sign, a 4-character grid square. It sends a transmit power, which is encoded, and then forward error correction. And it does all that in 50 bits. That's 50 ones and zeros. That's all it can put out. And it takes almost 2 minutes to transmit that. Whisper doesn't have altitude natively. So what we do is we encode the altitude into the power field. And once it's on the ground, we decode that. And I'll talk a little bit about that. And then, oh yeah, we do it by with a Python script that reads WhisperNet and decodes the altitude and writes it to APRSI, blah, 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 blah. I'll show you a better picture of that right here. How's this? And most people like pictures better. I know I do. So here's a balloon, it's transmitting. It's picked up by your HF radio. People are listening on Whisper all over the world. It gets, if you decode it and you do a good decode, it gets written up onto the internet to whispernet.org, and it sits there in a database. Well, every once in a while, my computer here, and you might see the black screen pop up for a moment because I do have a balloon in the air right now. The computer goes and queries WhisperNet, and it decodes the altitude from the power field, and then writes that up to aprs.fi. And from there, that's where most of the other systems pull their data to see, you know, where the balloons are, all the different balloons. And here's a couple examples. Any user, HabHub or ARHab, one of those is the US version, one of these is like the British version of amateur radio ballooning. And LU7AA is the AMSAT South America, also was the big telescope down in Puerto Rico. So those are just different people that use the data from APRS-FI. So that's how Whisper works. An APRS signal works straight into APRS. So it's picked up by your 2-meter radio, goes straight in. Well, if you decode it, it gets put out on the internet onto aprs.fi, and then people use it. So that's the 2 paths. Well, because the 2 paths are very similar, we can have a transmitter transmitting both, which is the balloon that's currently flying. It's transmitting HF and VHF. And if we get a VHF signal in, since it has so much more detail, we use that, and that gets posted to APRS-FI. But when it's not over range of a VHF station on the ground, and it sends out an HF signal, it gets written up to WhisperNet. And then every 15 minutes or so, my computer will query WhisperNet and APRS-FI, and it says, hey, do I have data from those? If there's no new update from APRSI, it'll go to WhisperNet and pull that data and then use it, even though it's less accurate, but you'll still have, you know, that the balloon's alive, it's moving, and where it is based on the 4-digit grid square. Now it sounds a little complicated, but it's not terribly complicated. So Whisper, here's just an example of a database entry in Whisper. Gives you timestamp and frequency, your signal to noise ratio, your drift in hertz. So that's over 2 minutes what the frequency drift was. So that's 3 hertz, and generally it's 0 or 1 hertz over a 2-minute period and 20 meters. So it's pretty stable, the transmitter, for being so small and being up in a very hostile environment. And then when you go across the line, you can see, you know, who reported it, how far away they were, that kind of stuff. There was also a GUI for Whisper that, you know, gives you out a nice map. So here the balloon is over Canada, and just to give you an idea, at 10 milliwatts, it's being heard here in this one example in Alaska, down in Los Angeles. Actually, my buddy was picking it up. Utah, you know, Oregon, and Chicago. So again, at 10 milliwatts, it's not a problem. It, you know, Whisper takes you a long ways. It's a pretty incredible mode. And then when it gets put up on APRS-FI, it does a lot of other cool stuff. It does mapping and it links between the points, so you can get an idea of where the balloon's been flying. This is a balloon we launched, I don't know, right at the beginning of COVID. So this one's just an example to show you what it looks like. And then here's an APRS entry. So it gives you a lot more detail, you know, just basically where it is in the information. Okay, so NCCBO 15, it is, as of today, it's been flying for 67 days. That's, yeah. It's done 6.5 laps around the world, and it's been flying between 40 and 45,000 feet. And the altitude changes a little bit as the weather changes, because as the atmospheric pressure changes, it'll change the altitude, because the balloon's really flying at an atmospheric pressure, not X amount of feet off the ground. It's got about 2,300 and some spots. That means that's how many people have picked up the transmissions from the balloon as it's flown around the world. The furthest location was over 5,000 miles away, and that was on Whisper at, again, at 10 milliwatts. So yeah, it's up there, it's flying. And this is not the right slide. So let me see what's next here. So when the balloon's flying, sometimes it's out of touch. Sometimes it doesn't report in. And we want to know, how do we know where it is? Or maybe we want to know where it's going to go tomorrow. Well, NOAA has a neat tool that they let us use. It's one of their supercomputers up in Colorado. And it's called the high split model. And you can go on their website, just NOAA high split. You can Google it. It's way easier than the long URL. And you put some data in there about the lat and longitude, where it is, what time it's there, and you can predict where it's going to fly. And it's incredibly accurate. And this model was designed to track things like volcanic eruptions, where the ash plumes are going, nuclear accidents where the radiation might spread, things like that, things that would end up in the wind and where it would go. So this model works great, and it's available to everyone. You used to have to get an account on their computer, which was no big deal, but now they let anyone go in and just use it. You can go in. So if you want to mess around with that, it's a pretty cool thing. You can also look at windy.com. If you've never looked at windy.com, it's a really neat website. It does this really graphical presentation of the Earth as a globe, and it shows you where the winds are blowing. And if you look at flight level 450, that's 45,000 feet, you get a picture of where the wind's going. And that gives you a very general idea of where the balloon's going, where the winds are, if there's any storms or really, severe low pressure areas, something like that. But you kind of put it together in your brain where you think the balloon's going to fly, looking at that. So where will it go? Well, this is actually a good picture. This is a NOAA high split model I ran a little while ago. And the last time I heard from the balloon was over Russia, down here where the star is. And that was Wednesday night. And the reason I haven't heard from it is because it was heading towards the North Pole again. It seems to be currently stuck in this loop where it flies over Russia here, over Siberia, and then over in the North Pole, and comes down over Greenland, and then Finland, and then back into Russia again. Sorry, this will go away in a second. And then back down into Russia again, over here, and comes around and does the same loop again. It's done this 3 times so far. It would be nice if it gets out of this loop around Russia and the North Pole, but it's kind of neat. As long as it keeps reporting in, it's cool. So this is the kind of path that NOAA gives you for the high split model. And so right now, as we're talking, it should be up here. This curved line here is the Arctic Circle. So once it gets up here, it's getting really close to the North Pole. So we should be up in here sometime. I expect to hear from it again on Sunday as it makes its way back down probably over Finland and Norway in that direction. So keep our fingers crossed, and we'll have another lap around the world. So some of the interesting overflights, all of our balloons, I'd mentioned the Emirates on the other flight, all of them have really neat stuff. And that's one of the cool things about doing this. As it's flying over these places, you can go on Google Earth and you can look at the ground, look at the satellite view, you see places. And the first couple laps of this balloon, it was stuck on flying over Ukraine and Crimea and Belarus, actually, and then down through Ukraine over Crimea. And now that's become, a hotspot in the world. And it's flown right through the middle of it multiple times. So I'm pretty lucky that nothing's happened there. But it's also flown over Afghanistan and Turkmenistan, Libya and Egypt, And one day it flew over Wuhan and Beijing, and there was APRS all the way, the whole way. So it had very detailed tracking. Every 2 minutes or so, we're getting a report back as it flew over these areas, and it was a straight line between them. And of course, it flew directly over Moscow, and it left Siberia. It's been over Siberia about 3/4 of the time that it's been flying. Mongolia, North Korea, Greenland, and Iceland. And this is the 3rd time it's been up at the North Pole. So again, this is one of the cool things I like about, besides building and launching them. Once it's flying, looking at, where are these places it's at, and how do they look on the ground, and do they look like where I live, or do they look like something totally foreign to me? Okay, well, that brings us to Quartz Fest. That's kind of my Pico balloon presentation. I'm going to show you a little bit of stuff from Quartz Fest, and then I'll open it up to any questions. So this is Quartz Fest. From what I hear you guys talking, most of you have heard of Quartz Fest, so I won't go into the details of what it is, but that's me doing a presentation over here. And this is part of the people that are at the presentation. Due to COVID, they spread things out, and we did a lot more outdoors in the open. It was really challenging without a slideshow, but this presentation and a lot of the other presenters really thrived during these presentations. So there was a lot of audience interaction, and it turned out really neat. This is our campsite. You can see our balloon assembly building in the background here. That's the tent. One of the things that Jed and I did is we put up this whiteboard and we started writing our flights on it. And this turned into Mission Central, I would call it. There were people out at this whiteboard day and night, and it grew from 2 or 3 people to, by the time we were ready to leave, we probably had 20 people or more congregating around. People came and had their coffee. People talked all day long into the night. It turned out to be a real central point of focus for people. We do have a little display out there with all the little components that we use to fly with. And one of the guys used his drone and he took some pictures of us, and that's kind of our campsite. You can see we got antennas up all over the darn place. Here's a balloon getting ready, one of the Chinese balloons. We're getting ready to fly it. It's got just a little bit of gas in it, so we have a little weight on the bottom, and we've been measuring it out on a little teeny scale, and we're getting ready to launch. And here's a launch. The wind generally has to be almost 0, but the wind was blowing all the time at Quartz Fest. So we came up and we can launch these smaller balloons because we have a much smaller antenna on them. We only had a VHF antenna, so it was way easier to launch them. The big balloon had a full 20-meter dipole, and that was a big challenge to launch. And you can just see that the group grew and grew over the time we were out there. Here's the one that's flying now. The two, the yellow and the blue spool is the 20-meter dipole rolled up on it, is to try to keep it so that we could unspool it when we get it out in the dirt there and not get tangled in it. But you can see the 2 solar panels and the tracker there in the middle. And there's the balloon. It's filled up. We've heat sealed it, and we weighed it twice, and it's ready to go. I'm doing the final connection between the balloon and the payload right there. That's N6JED. He's holding the balloon. I'm trying to get the antenna out without it getting snagged or broken, and get the tracker on the ground. And then I'm trying to, right there, string out the other side of the dipole. And then we had this coordinated ballet, because as soon as we got out there to launch it, we started getting a breeze, and we needed to walk with the balloon, and we let it up. And there we go. We had a successful launch, and there goes the balloon. So this picture, this is a picture of a board of all the flights that we had. And maybe some of you guys know Gordon West. He wrote a lot of the books on ham radio and the training courses. Some of you probably are Gordon West instructors, maybe, to teach. So I grabbed Gordon and I said, "Hey, Gordon, would you take our picture?" And he is laughing because he said hasn't had in years someone ask him to take a picture. He's always been in selfies. Everyone wants a picture with him. So Gordon West took our picture here, and it was pretty funny. He got a good laugh out of it. And so some resources. Really, if you want to talk to people that are really experts on this, you want to do groups.io. There's a Pico-Ballooning group. So if you want more information, there's a great archive there. Lots of people participate. There's people that have little different pieces of this hobby. There's people that want to build hardware, so they're building their own little trackers. There's people that love the software piece of it, so they're changing software and writing software for the Pico balloons, for the trackers. Also JavaScript for the ground, when to pull the data down and pull it apart. There's folks that just like experimenting with the balloon envelope itself, so they pump them up with aquarium pumps, and they use Raspberry Pis and all this stuff to analyze, when the balloon will break or how long it'll float for. So there's lots, like everything else in ham radio, there's lots of little different pieces of this you can, chase down. And then finally for tracking, again, APRSFI, whispernet.org. You can use NOAA High Split to predict where it's going to go, or windy.com. And there's also ARHAB, which is the British ballooning website. And then some various trackers. This isn't all of them, but this is the major commercial ones. There's lots of folks that are building their own now, because it's all open source. And then balloons. The SBS balloons come from Scientific Balloon Solutions. So that's pretty much it for me. I hope that was interesting. It's a little hard on Zoom where I don't have that immediate audience feedback. So hopefully I kept you guys entertained here a bit. Do I have questions?
I can assure you that it was very entertaining and informational there. Fabulous stuff. I haven't been watching the chat there. Joel, did anybody already have questions posted? Okay. So, I see Shri here in the audience, so bear with me as I try to filter through any questions. It's difficult to see here on the screen, but let's see what we got. Let me give the mic over to Shri here.
A couple of questions. One, your slides were very interesting. Is there a possibility you'd share them somewhere?
Can you repeat that again?
The slides that you used in this presentation today, it was quite interesting. I'd like to go through that with some of the kids that I'm working on a similar project with. So is there a possibility that you would be able to share the slides somewhere?
Sure. Why don't you email me just on my call sign? You can just do ARL.net, and I will talk to you offline.
Very good. Thank you. And the question I had was that the Chinese balloon that you mentioned, 36-inch, that looks like it's not aluminized. Is that right? It looked like it's transparent.
That is correct, and that always brings up a bunch of discussion in an area that I'm not very well versed in, but it has to do with thermodynamics and the metallized balloons, because at the high altitudes they're conductive. They don't conduct heat very well, but the radiant heat does. So what happens is you can actually get hot inside the balloon and expand the gas more than normal with a silver balloon than you would with a clear balloon, which seems counterintuitive. But if I trust the guys that really understand this stuff, that's what they tell me.
Where did you get those from? That was
where do we get the balloons?
The transparent 36-inch balloons, because we've not found those anywhere. So I was curious to know where you got them from.
Those came from AliExpress, I think.
Okay.
So basically China.
Okay, thank you, Shri. And hang on a quick second. I got two on Zoom. We'll kind of thread back and forth because I don't want to lose my Zoom audience there. Good question. Charles, if you just want to bring up your mic and ask your questions directly. I saw you got a question.
Well, as an educator, I'm kind of interested as to the cost of materials for each launch. In other words, how much for the transmitter, capacitors, and the solar panels and the like, and the balloon itself. I think you mentioned that already, but if you could mention that again, that'd be great. Thanks.
Sure. So you can spend, on one of the commercial trackers about $110. There's probably another $40 in materials and stuff there. So you might be into it for $150. If you use a commercial balloon, you could be in this for a little over $300 for one of those. On the other end of the scale, if you use one of the PC board manufacturing companies out there and use some of the shareware, the PC designs, you can get a board for $8 and you can populate it. If you can get the chips now, and you can use a cheap pair of cheap Chinese balloons, and you can get flying for under 50 bucks. So it really depends on how much effort and how many hours you want to put into it.
Very good. Thank you so much.
Sure.
Okay, Bo, I know you're in the queue, but let me grab a question from the audience real quick.
You mentioned the power field as an altitude measurement. I was kind of curious how that worked.
Oh, sure. So, oh boy, let me explain it. The power field, what you do is you take the altitude in meters, and you basically just encode it as a power, whether it be 1/10 of a watt or 2/10 of a watt or whatever it happens to be, and you encode it into that. It's pretty much that simple. When you receive it on the ground, you receive 0.01 watt or 0.02 watt. You run that back through a formula that converts it back from that, whatever that number is, to meters of altitude, and then run it through another conversion to change that to feet. I don't know, is that kind of, we're really just hijacking the power field. And Whisper, normally when you have a transmitter, you want to transmit your power level that you're transmitting at along with it.
Okay, and we have a follow-up on that question. Here you go.
Sure.
So is when you're lying about the power, I mean, putting the altitude there, is there any one particular value where the 10 milliwatt does come out right? I mean, for instance, for 33,000 feet, is it 10 milliwatt by chance? You see what I mean?
Yeah, there is.
It's cute. It will be interesting.
Yeah, I'm trying to think what it is. It's 3,000 meters, I think it is.
All right, thank you.
But I'd have to look at the chart.
Okay, it's hard to see on the screen here because it's just doesn't have the grid. I can't see if anybody's waving their hand. Any additional questions, just shout on Zoom or here in the audience. Oh yeah, Bo, Bo, you can come up. I'm not sure if we answered your question, but go for it. Okay.
Unmute your mic if it's muted.
Unmute mic, Bo, are you up? Okay, Bo's question. Oh, there he is. K68. You're up there, but I'll tell you what. He said, what happened to the Whisper altitude encoding deciding? Please relay. Yeah. I'm not sure what he means there. The Whisper encoding.
Decoding.
Decoding. There we go.
I'm not quite sure what the question.
Was it already answered? Oh, okay. I think it was already answered by the other question there. Okay. Very cool. Anybody else here in the audience? Oh, we got a couple. Let me go here and I'll go over there.
Okay, so there's a question here. Let me answer the question that's up. I understand what he's asking now. So APRS was reporting some bad data on the altitude on this balloon for a long time. And actually it still is. It just doesn't look like it. What happened is I made a mistake. I screwed up. So we have a process in place where when we change any of our software settings on one of our trackers, we go back into our ground testing. That means we set the tracker outside in the sunlight and we make sure that the solar panels work and that it transmits the right data and we decode it and all of that, and it works fine. Well, in the rush, just before we launched out at Quartz Fest, I decided I was going to change the message that was in the balloon tracker. And so I jumped in. It was a very simple change. I changed it and all should have been fine and dandy, except I uploaded the wrong file to the tracker. And then we launched it. So what it's doing is it didn't transmit the altitude as a power field. So that got transmitted and uploaded to APRS and it had bad data. And it was flying like that up until last week. And then what I did is I went in and we made a change to the script. So it looks at the last APRS altitude and it just dummies in a Whisper altitude. So it's sort of right, but not really. But again, that's because I got launch fever and we violated our own process that we had come up with. And the funny thing about this, to diverge a minute, is I was working with some engineering students at Cal Poly in Pomona. And I just hammered this into them about how they have to have procedures and they need to follow it and all of this. And then I went ahead and violated those and turned around and bit me. So that's how we ended up with bad data, and that's what you're seeing now is a sort of a fix.
A quick question.
Yes.
Yeah, Andy, KL60. Were you able to reprogram the balloon when it came close to where you were at the time, or some days later, or not? Turn down the radio here.
No, the tracker can only be uploaded by direct connection to the computer. So no, we're not able to reprogram it in flight. What I did was I was able to modify the JavaScript that reads the whisper data and basically come up with an altitude from the last known APRS altitude.
Well, I forgot. You said you didn't have a receiver, only a transmitter. That's right. Okay.
Question?
Yeah.
Hang on, everybody. We got to run this like a controlled net now because we've got air traffic control going here. I've got 2 in the audience, and then I'll come back to Zoom. Here's Connie. Connie, go for it.
I thank you very much. I have a couple of questions. The first is whether the balloon that is currently flying and has been flying for 67 days and done a couple of circumnavigations is one of those commercial based $300 jobs, or is it a $50 garage job? And the second question is about flying over Ukraine, which banned amateur radio transmissions during the war. And I was wondering if that has created a delicate situation while the balloon was flying over. Thank you.
Oh, good questions. Well, the balloon that's currently flying, the easy answer is that's an SBS 13 balloon. So that was $157 for the balloon. And then the trackers and all the hardware. A lot of that stuff we've gathered up over time. So that's kind of that question. As far as the flying over Ukraine, yeah, that's an issue. We do our best to try to do the right thing. The transmission is 10 milliwatts. We've been lucky so far. We haven't actually violated it. And that's really by luck because the balloon had a long night. So it flew down over Russia, Belarus. And when it got near the Ukraine border, it was in the evening time and it went dark. So it's flown over that area numerous times, but didn't transmit in that area. Again, that's via luck. So it would be nice if you had some way of being able to command the balloon from the ground, but we don't really have that, especially without ground stations.
Okay, let me get a couple other questions on Zoom. Dave, I see you up, and I think there was somebody else. So Dave, take your question, and then we'll go to some of the other ones there.
Oh, sure. I just was commenting that your last minute patch that fixed the bug, but actually created a bug. You said you were not an engineer, but that's exactly how us software engineers do it. You know, we fix bugs and create bugs. And then I had just a joke question, which was, watch out for the official observers in Ukraine.
There you go.
But cool talk. Thanks.
Well, one thing that's interesting though is there was a lot of APRS stations in Ukraine, so you could see those on the map before, and there's a few of them that have been still transmitting. So, you know, it's just interesting to find that out. There's lots of them in Moscow. My gosh, you fly over Moscow and you look at APRS, and it's pretty incredible. You can see the guy delivering bread and running around in his truck that's got a ham radio and an APRS. So.
Okay, I see Rich, you've got your hand up.
Yes. How do you know how much gas to put in the balloon? And is that based on the type of the balloon, etc.? This is Rich, W6APZ.
Rich, that's a great question, and it's a very delicate balance to get the right amount of gas in. We know we want to have a certain amount of free lift. So free lift is the amount of lift in addition to the weight of your payload. And excuse me, since this is a super pressure balloon and it's not like a latex balloon, it doesn't expand. Because of that, the amount of gas you put in really doesn't affect your float altitude. It affects how fast you get up to your altitude. The volume of the balloon, the semi-fixed volume of the balloon really sets your float altitude. But the amount of gas you put into the ground determines how fast it rises to altitude and then what the pressure is once it gets to altitude. Now, what's important is you need to get the balloon up to altitude fast enough so that it doesn't ice up. Because as it goes up, if it gets a little bit of icing on it, it'll bring it down. And we've had balloons come down for that reason. On the opposite side, if you put too much gas in it, it'll rise nice and fast, get through those areas of the atmosphere where there's moisture, get up into the dry, 35,000 foot range. But when it gets to float altitude, the pressure inside will be great, higher. So you have a much higher chance of the balloon developing a leak or puncturing or rupturing.
Very cool answers. Let me throw this over. You had a question, sir? There you go.
Two questions, actually. One, have you ever recovered a balloon?
No, we haven't. And I only know of one person that did, and he was assisted by the Polish army, believe it or not. They were doing their summer exercises, and a balloon went down in a forest in Poland. And the commander was one of our ham radio operators, or a fellow ham radio operator, I should say, also a Pico-Balloonist. And he had all these troops, and he was trying to find something for them to do. So he sent them on a search and recovery mission. And they spent about 7 or 8 days looking for this balloon, and they found it in a tree in Poland, in one of the one of the forests. That's the only one that I know of that's been recovered.
And the question was, can you talk about the antenna wire, like the gauge, the type, stranded, solid?
So for the VHF antenna, it's a 19.4 inch, tuned basically for the APRS part of the band. And we found that we can use a certain brand, this Eddie Ball guitar string. And the reasons we ended up finally getting to that is it's very springy, so it straightens out nice and straight. It doesn't get tangled and knotted. And the other key feature with that is it's solderable. If you get some stainless steel wire, you can't solder it. But this guitar string works great. It's available, and it solders beautifully. With that in mind, when we were struggling with different types of 20-meter dipoles, we tried different things. We came up with this piano wire, and it's 5/1000ths of an inch. And it solders beautiful, and I would say it's not impossible to get tangled, but it's possible to deal with it. You can spool it up and unspool it without it being impossible to deal with. The drawback is that wire that we use on a 20-meter dipole is so thin that if you get near the end of it, it'll go right through your finger before you even know it. I mean, it'll literally go right through a thumb, and you'll be sitting there with it in your finger. It's incredibly thin and sharp stuff. So we take extremes to make sure we round the ends off. We put little swivels on it and stuff like that, tape it down to make sure it doesn't get away, mainly for our protection, but also for the protection of the balloon when we start to get ready for a launch.
Oh, great questions, great answers. Okay, anybody on Zoom, go ahead. Do we have anybody? Oh, anybody on Zoom, go ahead and chime up that might have any more questions. Bueller, anybody here in the room? Going once, going twice. Brian, thank you so much.
Thank you.
That was very informational. I enjoyed it. Yeah, thank you for your time and coming. You're in Southern California, right?
Right, I am down here in Acton. Acton's just, I don't know, Los Angeles is the closest big city, but we're in the mountains just south of the Palmdale, Lancaster area.
There you go.
Are you going to be at Quartz Fest?
Yeah, Quartz Fest next year.
I don't know. We'll see. Again, the reason we had so many balloons and so much material to launch was during COVID. We had been, acquiring this stuff, and we hadn't been doing any launches. So
well, and it just dawned on me that You're explaining all this as if you have this like major money laying around, but you're talking about 150, almost up to $400 that is just lost eventually. But the reward is the traveling and the education. And I'm sure that even though it's a lot of money, the rewards to many people are exceptionally wonderful.
There's a incredibly diverse group of people that watch these balloons, from my friends over at JPL that, you know, just fascinated with what we can do with, you know, to them, this is no money at all, to, you know, schools and people. I know that I have a lot of XYLs of ham radio operators that are more fascinated in this than the actual ham radio operators. So it just covers the whole group.
Fascinating. Okay, thank you so much.
You're welcome.